students, only three theorems remains to complete our syllabus group theory first of this semester. It will the first theorem is first isomorphism theorem, and similarly there are two more theorems which are second isomorphism theorem and the third isomorphism theorem. So in this lecture we are going to discuss first isomorphism theorem. So first we will understand the statement of this theorem. In the theorem, it is stated that if there is a group G and there is one more group G dash, this is a group which having some elements, and this is one more group, this is G and this is G dash. Here, phi, which is a epimorphism. Epimorphism means phi is a homomorphism and it is onto also. Onto means there is no such element in G dash which is not the mapping of any element from G. If there are these four elements in G, then every element of G dash will be the mapping of G, and this mapping phi is also homomorphism. Further, there is a quotient group G upon K. As you know that about the quotient group. Quotient group is the uh, group of having elements right cosets, and this is isomorphic to G dash. It means if phi is epimorphism, then it will be also isomorphic to G dash. So this is the statement of this theorem. I hope you have understood about this theory statement. I am repeating again. Phi is a epimorphism, and we wish to show that this phi is isomorphic to G dash over the group G upon K, where G upon K is quiescent group, and in here the K is a set of such elements which mapped on identity. It means the element of K is kernel. So let's discuss the proof of this theorem. As per the statement, phi is a mapping from G to G dash. We have written it here. If this is a mapping, then there will be few elements in such a manner. Let us suppose this is the element and the name of this element is G. This element is G. So there will be one more element in G dash, which is G dash. Here the mapping of this G is G dash. So these are two elements. One is G and second is G dash. G dash is from G dash and G is belongs to G. And here we are seeing that the mapping of this G is G dash. Now we will define a mapping psi, because here we wish to show that this G upon K is isomorphic to G dash. It means there is a mapping uh, from G upon K to G, and this mapping is isomorphic. So we are naming this new mapping as psi. First we will define this psi. It means here the elements of G upon K are being mapped on G dash, as I have discussed here. So, and we know that the element of G upon K, it means the element of quiescent group will be of the form of right coset. So let us suppose this is Gk. So this will be the element of this Gk will be G dash, because G dash is the element of capital G dash and this is the element of G upon K. It means any element of this side will be mapped in this side. So here we have assumed that this Gk is being mapped on this G dash, and we have, as mentioned here, this G dash is the mapping of any element, because this is one and onto mapping due to epimorphism. Every element of this G dash will be the is the mapping of the element of G. So this G dash will be also a mapping of any element, and we have already mentioned our suppose here that this G dash is the mapping of this G. So here we have established a relation psi of Gk, which is equivalent to G dash, and that is equivalent to phi of G. It means we have mentioned a relation here between psi and phi. So this new mapping psi can be used here. It means it is well defined. Let us suppose there are two elements in G. which are G and G1, and here we are generating two elements of this quotient group, which is the right coset Gk and G1k. With the help of these two elements, we are generating two elements of quotient group, the Gk and G dash k. And if these two elements are equivalent, let us suppose these elements are not distinct, then if these are equivalent, so on multiplying both side by G inverse, and we know that this G inverse and G1, these are the elements of uh, G. So their composition is possible here. This composition is possible here. And here we are seeing that this side is equivalent to this. It means this G1 inverse G inverse G1. This is multiplying on this K, and result is also K. It means no new element is generating here, which is only possible if this composition is the element of K. Otherwise, it will generate new elements. So here the closure property is being satisfied, and no new element is being generated here from after multiplying G inverse G1 on K. So this combination or this composition will be also the element of K, because this is the element of K. So it will be mapped on identity in G dash, so which is the definition of kernel. So here the mapping of this element, this composition, will be equal to identity. Here we are assuming that this is G and this is G dash, and this is the element G inverse and G1, and this is a closure composition of two elements, and this is being mapped on a element which is identity on G dash. So this is result is true. Here we are applying the definition of homomorphism. On the definition of homomorphism, the mapping of the product of two elements will be equal to the product of their individual mappings. So here we have obtained this result. Now we are multiplying both sides by phi g, and after again we are using here the definition of homomorphism. We are taking these two elements simultaneously, and these are being mapped on identity. So this will be the mapping of identity, and we know that identity is always mapped on identity in G dash. So this result is equivalent. It means G1 dash is equivalent to G dash. So here we have seen that if the two elements are identical, here we are assuming that, I'm defining it again. Let us suppose there are two elements. The first element is Gk, and the second element is G G1k, and we are assuming that these two elements are being mapped on a particular element. As we have mentioned here, these two elements are equivalent. So with here we see that this G and this G1, these are not new element, these are the same element. So which is the mapping of psi. So here we are seeing that this psi is 1 1. In the case of 1 1, we see that if the mapping of two elements are equal, then these elements will be also equal. So this is the definition of 1 1. It means if we are taking elements equal, the mapping of two elements same, then the elements will be same. This is the definition of 1 1. Otherwise, it will be treated as many one. So here we have seen that this mapping psi is 1 1. Again, now we want to show that this psi is also onto, because we want to show it as 1 1 onto. Let us suppose there is an element which in G dash. This is the G dash, and there is an element which is G dash. And we know that the every element of G dash is the mapping of G of any element from G. So we can write it here as phi g. G dash equal to phi g, and earlier we have seen that the phi g is also equivalent to psi of gk, because there is a relation between phi and psi in which we have defined the psi. So this G dash can be written in terms of psi. So here we have seen that every element of G dash is the